All right. Hello, everybody. This is Kubernetes SIG architecture meeting for August 21st. And we have one agenda item. I will share and hand it off to Michael and Jordan.
Cool. Yeah. So, yeah, let's wait for the thing to get presented. But yeah, thanks, Jordan, for adding this. Basically, this has been brought up again because of storage version migration, but I think Jordan wants to expand it a little bit more. But basically, yeah, thoughts on um, increasing some of like the requirements for resource version requirements. So basically, storage version migration has the concept that resource version needs to be monotonically increasing and an integer. So I think we already agreed, like in SIG API machinery, that this is fine to add, and it's already how etcd and stuff like that do resource version. But we wanted to get like sign off from what's it called, from SIG Arch, just to see whether or not like this is kind of a good way to go forward. And yeah, Jordan, if you want to add.
I think that's a good summary. A couple more details. I tried to, this is like the 15th time this has come up. I tried to find all the places we talked about it in the past. There were some good links to like places where we tried to see how people in the ecosystem were either already assuming that this was an integer, which is pretty, I don't know if it's common, but you can definitely find plenty of examples of it where people already assume it's an integer, because in 99.9999999 rounds to 100% of clusters, it is an int64. Anything backed by etcd, anything with built-in standard Kubernetes APIs or CRDs, it's an uint64. So there's plenty of things assuming it's an integer already, and there was a link to some places where we were seeing people do stuff with that. We know of at least one sort of weird aggregated API server that kind of hand wrote their own serving, and I think they did something clever to back their resource with maybe a CRD or something, and then they were like smushing together random things into the resource versions. They were using it to like record the UID of the CRD object that it came from, plus the resource for, I don't know. It was weird. So we know it's like an existence proof.
I have another one, right? And which is using a commit hash.
Yeah.
For
anytime we find, like, these things are obscure enough and rare enough that they're actually pretty hard to find. So if you know of some, like, drop breadcrumbs in maybe here for now, and we'll copy them into whatever proposal we end up making. So we have existence proofs that there are servers doing different things. They're not using the standard Kubernetes server framework. They must be using like a hand-rolled thing. So it's kind of an open question. If we go down the road where we say all of the standard Kubernetes machinery is going to produce resource versions that are comparable integers, like of some bit length we can figure out. So if you are using standard Kubernetes resources and custom resources, you can rely on these things being comparable integers. That's like sort of one level of a statement we could make. If you're going to write a controller that operates generically across all resources, like garbage collection or quota, we have a couple of them, and you want to use resource versions as comparable integers, our storage version migration, we would like to be able to run generically. What do you do if your generic controller gets pointed at a resource that's a weirdo resource that did something non-integer, non-comparable? So we would at least have to describe what to do there. If you're going to write a generic controller that's working against things that might be not handled by standard Kubernetes machinery, at least have an error path where if you encounter weird resource versions you can't compare or don't parse, you surface that, or you fail in a safe direction, or you have a fallback path that's less efficient, or whatever makes sense in your scenario. That's sort of the middle ground of like recognizing other people did weird things and telling people who want to handle stuff generically, be prepared for weird things. And then like the most strict we could be would be to try to rein in the aggregated servers and say, like, we're going to try to do something to detect that you're misbehaving and like say you shouldn't do this. So that's kind of the other extreme. Yeah. So a stronger statement around built-in Kubernetes stuff and custom resource stuff, so that people who are writing controllers against those things can like depend on resource versions meaning a particular thing. Good guidance for how to write generic controllers that handle weird resource versions if they encounter them, and then maybe like trying to think about what we should tell aggregated servers that they should be doing.
At least for like storage version migration and that kind of stuff, like we can always say like we just don't support it, but for other things like garbage collection and things like that that are more like pivotal to like the actual like flow of Kubernetes itself, like that might not be possible. So we would need to see what we want to do for those kind of scenarios.
I can't remember. Did David make the call? He said he might not make it. He had a couple comments in Slack, so I will. I'll channel David and bring in his feedback. So the first thing, he was in favor of relaxing and the guidance and saying these are comparable integers in general. So that was the first thing. Second thing, he was in favor of a constrained bit length, and he liked int 128 or uint 128 just as something which seemed like big enough for anything that wasn't insane, but also did have an upper bound, so someone couldn't put like a megabyte long resource version string. And then the third thing, he pointed out that whatever we give clients to parse or compare resource versions does need to have like an error possibility in the signature, so that if it's given to that don't parse, like it's a signal that you can compare these. We don't expect this to ever error if you're working with standard Kubernetes resources, but the possibility is there that it could error if you're working with something else that's misbehaving.
Okay, I think I'm first in the queue. So I think a couple of questions. Well, one is, like I said, I do know of at least one other case. I don't know if it's still done this way, but I think so in that project. And so forcing it to be that seems risky because, right, we know that there are thousands of ecosystem projects and we have zero visibility and control over them. And if we just break them all, I think we will potentially have some upset end users. So I'm wary of that, but I would say that if you could control it, if there was metadata somewhere on the kind to say for this kind it's true, or even if we just literally said for anything that's not an aggregated API, it's true, right? That kind of seems like it could be viable. The other question I had is as I seem to recall, the reason this is specified in such a way was to allow sharding of individual types. So you could have independent storage. Like right now, it's easy to have independent storage backends, across types. But within a type, nobody does it as far as I know. But theoretically, with this non-comparable thing, you could do that, right? You could shard an individual type across multiple storage backends because you don't need a sequential. There's no single monotonically increasing integer you need. And so we would be giving that up. Now, we've been around 10 years and nobody's used it, so maybe that's fine. But it's something we need to be aware of. And if that's the case, what I'm curious about is for the actual use cases for which we want this to be monotonically increasing. Is it that we want it monotonically increasing within the scope of the resource type? Or is it for an individual resource, you want to be able to compare these? Right. So I want to see that this version of pod foo is newer or older than this other version of pod food that I have. Or is it that I want to see that pod foo is, more recent than pod foo bar, right? Like which is different, right? It's like one's a tighter restriction to say that for all pods it must be sequential. If you say for an individual pod it needs to be sequential, you still can do the sharding, right? Because your individual pod can land on that same storage zone, and your local storage incrementer can still keep track of that. So what is the real need, and can we do the least restrictive thing to meet that need?
Yep. So starting with the first question, talking about sharding. Whatever is serving that resource type still does need to be able to produce an ordered, linearized stream of objects. So even if they sharded storage into crazy things, like when the client does a watch, it still needs to get back all the objects in order. So
across objects, we guarantee across objects, not just
that's
100%
within a single type. A watch is scoped
within a
to
type, yes.
type, but yes, across objects, definitely across objects.
Yeah.
Okay. And so maybe
so sharding is not really feasible
anyway. In a crazy custom resource version, if all you have to do is make it a string, like you can make it, you can go nuts. Like you can have, sharding tokens and like piping and joining, like you can do anything in a string. So maybe it's easy to encode like your crazy sharding strategy in a way that you can like bring back together. But the server still has to produce a single linear stream. So there's also ways practically to like shard out and then but encode that in an integer with sufficient bits. So if you have enough bits, you can make anything an integer, right? So you could use high bits, and like that's part of the reason for expanding the bit size to say if you're going to do crazy things, like, all right, we'll just give you enough bits that you can do crazy things, and kind of like the first 32 bits are this, and the second 16 bits are this, and the next 16 bits are this, and then the last 64 bits are, what traditionally was the resource version. Who knows? So to my knowledge, no one has used resource version being a string to do sharding. Second, the server still has to produce a linear stream, and it has to be able to do its own like internal comparisons to know this came before that. And so if we make the integer sufficiently large that we could like plausibly sketch out how someone who wanted to shard could encode their sharding scheme into the integer resource versions, I don't think we're actually losing a lot by saying this is a comparable integer of like bit length 128 or something.
So then the other question of, can we do this either for so the root aggregated APIs, or
the two most immediate reasons we want to be able to compare this on the client side are across all objects of the type. So storage version migration is migrating all instances for a given resource type. So it's going to do a list, and it's going to progress through the list in key order. And then if it gets interrupted at some point through that list because there were like a trillion objects or something, it wants to be able to pick up at that point in the key order and at that point in time. So, or not time, but say anything with a resource version lower than when I started doing my migration at this point in the key space. So it cares about resource version comparability across all objects of that type. So that's the first case. The second case is controllers who are writing lots of objects of a type. So like a daemon or a daemon set controller reads a daemon set, writes a bunch of pods. It would be nice if when it ran through its sync loop and wrote a bunch of pods, if it could say, okay, the last pod I wrote for this daemon set was at resource version 123. I probably shouldn't like resync this daemon set and take more actions and maybe create more pods with this daemon set until my pod watcher has at least observed resource version 123. Like, I'm going to write a bunch of pods with this daemon set, let my local cache catch up to what I just wrote before I start trying to like write more pods for this daemon set. So again, it cares about resource version for every
across instances. Yeah, but still all within the same type.
Yeah.
And so,
yeah.
right,
We're not proposing relaxing that.
So yeah, of course not. But so since it's within the same type, my question was actually whether we can make this a metadata piece of information about a type, right? So that any controller that needs to depend on this behavior can check if that type supports that behavior. Or if that's too painful, like, can we literally just say, this is how it behaves now for everything except for aggregated API types? Because that rate, again, it's the least change. And we're not going to break things that aren't, the only things we're worried about breaking are aggregated APIs, as far as I can tell.
Is there anything else besides aggregated API that might use the string resource? And also, how would we detect whether or not it is like an aggregated API?
I mean, we should know if it's an aggregated API, right? But whether we know it in the right places at the right times is another question. But there's a lot of other hands. I made my points. Like, we don't have to answer it here if we don't know, but like, let's let other folks get their points in. Mo, I think you're next. At least on my list.
So I think what I'm curious about is, so I think I could agree with the semantic that's basically like, hey, if it is a built-in resource or a custom resource, we can treat it as such. I'm curious about how strict would we be, right? So like in let's take Jordan's example of the daemon set controller, right? It's working with daemon sets and pods, right? These are built-in resources. So we just know they're built in. When it tries to do that comparison, if it ever gets an error, what do we expect that controller to do? Because I think it's not like the storage version migrator where you could just kind of fail the migration and say, well, I don't know how to migrate your resource, dude. You go figure it out.
Another question is if they're just using ints, but they're not like monotonically increasing, right? Like they just put some random hash or something like that.
Yeah, that's like maybe the second question. That's like you're violating the contract without making it obvious you're violating the contract. I was first starting with like you put an emoji in there, and I don't know how to turn an emoji into an N64.
Yeah, I think like what does fail safe look like in a particular context probably varies. Like sometimes it lets you sometimes it's an optimization, sometimes it avoids sort of flaking or doing sync loops prematurely. If you have a controller that says my local cache is at this resource version and the last write to this type was at that resource version, is this less than that, and it gets an error, like I probably would tell if the controller says, I think I want to sync, is my cache up to date? And it's like, I can't tell you. Then today, like the daemon set doesn't even consider this, it just syncs. So I would probably have it just sync. Like, but I don't know. I'd have to think about the scenario.
Okay. It may be up to each controller to figure that out, but right.
Like storage version migration is like, I got to this point, I want to restart. I want to consider, like, I want to skip this object if it was written after I started my sync. and I get a comparison error. It's like, well, maybe I won't skip it. Maybe I'll just do my no op patch. Like it skips the optimization, but if it can't figure out if the object was older than when it started, just try to migrate it. I don't know. That's probably what I would do.
To separate, is there a controller that would care outside of storage version migrator? Because for me, the optimization or like the comparison that you described is something on the lower layer of informer that can make decisions like watch cache. Am I fresh enough? Can I compare this? But externally, like when you expose the API, like no one, like it's still, then you go back to comparison. It's just for internal machinery of like caching.
I mean, all the controllers that take some parent object of one type and make a bunch of writes to instances of another type, like it would seem sensible that they probably shouldn't like resync that particular instance of the parent type until the related child writes are observed by their store. Like that kind of, we see problems about controllers like operating on stale state, not recognizing the writes they themselves made the last time through the sync loop. That's a general pattern I would probably try to find a way to make easy for controllers to do.
Yeah, the specific example I had put as a comment about when we added pod certificates, the volume management to kubelet this last release, it doesn't know if it just hasn't observed its own writes to the API or if those writes had been observed and then deleted by the cleaner. So it just like waits 10 minutes. And if it's like, oh, it's been 10 minutes since I tried this, I guess my informer is up to date and I don't see it. So I guess I'll try again.
Yeah.
Han, I think you've been waiting.
Yeah, so I personally vote for uint 128 to give ourselves the padding for future flexibility.
Okay. So, crap, I had another question. Oh, is the proposal here I guess it doesn't, like how, so the question came up of like, well, what if somebody just supplies, crap, but who's somebody, right? It's like the storage layer, right? So like how is that, in an ordinary API, we validate because you're writing the value. In this case, you're not writing the value is generated internally. And so would we just consider that a misbehaving storage backend, except in the case of an aggregated API, if we're not requiring this in aggregated APIs? Like I don't know, it feels like maybe just too small of a, like we just throw errors and that thing doesn't work. Like that would that would be
right now, if you pointed at something that spoke the etcd protocol, etcd wire protocol, the etcd wire protocol actually works in terms of like int64s. So it's not even possible for
something that's backed by etcd,
that is backed by etcd or something etcd wire protocol compatible to do anything other than int64s. So it's only aggregated API servers,
right,
or things that aren't running Kube API server.
What are I know that there's some like distributions or variants of Kubernetes, and maybe they're not conforming that back with SQLite, like, and do they use the etcd wire protocol or do they swap out the storage layer?
I don't think this matters here because watch cache has been comparing order of revisions from etcd for a very long time, and it always depended on it. So we never exposed it externally, but it's expected internally for storage layer for a very long time.
Okay.
So one possibility would be to add to conformance tests something that looks at resource versions of the APIs, like the standard Kubernetes APIs that conformance already cares about. Like it already exercises the pod API and the node, like all our GA APIs.
Check that they're increasing.
Yeah.
Yeah.
One possibility would
integers.
be to have a check for all of our GA included in conformance built-in API types. The resource versions coming back for instances of these things are parsable as this.
Yeah, as these integers, and they're monotonically increasing.
So that even if you were running a fork of Kube API server and against something that wasn't etcd, and you had hacked out all of the things that relied on it being in 64, conformance would still be like, you have emojis in your resource versions for pods. What's wrong with you? Yeah, I think conformance is probably the right place to hang stricter requirements, like more enforcing requirements for like APIs that the Kubernetes project owns. And then to say, if you're running aggregated API servers, like conformance doesn't go look at those APIs. If you're doing crazy things, you're going to hurt your users. The more they rely on this, the less well they're going to work with you. But like we can say stronger things about pods, and the way that shows up is you don't pass conformance if you're serving pod APIs in ways that break how people have written controllers that expect to work against pod APIs in this aspect. You're muted, Ben, if you're trying to talk.
Well, I don't know if Mo or Ben.
There was a
Mo still
line.
got a hand up.
Yeah, there were hands up.
Okay.
Yeah, I can go real quick. So I want to dig in just to, I think, what Merrick had said and about the. So I have the link in the agenda for need to decide on these open issues. That one in particular, I think what you're saying, Merrick, is all of those are sort of, we don't need to do any investigation, because if any of those backends is misbehaving in the way that they could be, either they're not monotonically increasing or they're not matching in 64 semantics, then they're just not going to work out with our watch cache. And maybe that's good enough in the sense that if you're literally going to replace all the internals of your API server and completely build something bespoke, then if we add the conformance test, that's roughly checking RVs, incrementing.
The watch cache is still part of the internal guts of the API server. If you've hacked your API server to do crazy things, like you either have to make watch cache work with your crazy stuff, or you have to turn off watch cache in your server. Conformance stuff is from the client perspective, saying like, I don't know what you did in your server, but what's coming back across the wire to a client has these attributes.
Right. What I'm trying to think through is, so some of these issues I had opened up as we were trying to work through the SVM stuff. My gut is telling me that perhaps we don't really need to dig into these because there's enough guardrails in our code to enforce a particular behavior. And then if we add the conformance test, that's like the outer client side behavior. And if you are willing to go off the path so far that you make a real Kube API server that serves like pseudo pods that don't conform to what we think, I don't know, you probably don't care about any of this stuff anyway, and you're just doing your own thing.
Yeah,
David's point that whatever function we give a client to do a comparison needs to have a signature that makes it clear an error is possible. So they at least consider how to handle the error.
Right. Yeah, I agree with that.
Yeah. Just quickly on the storage layer, Kubernetes has supported semantics for lists that requires this behavior for a very long time. Like you had always had any resource version, but also not older than. And to implement not older than, it's not even watch cache. We implement it on storage layer.
So, right, but it's internal to the server. So we've always told clients, don't compare resource versions, but the server has always needed to compare resource
Yeah,
versions.
yeah, but those issues we don't need to investigate. We don't need to look at other like projects that re-implement storage or even replace storage. Or by storage, I mean once replace etcd and other replace the storage interface, because they were always expected to provide semantic that compares some global logical counter.
We don't need to worry about the API server implementation, like relying on comparing resource version, because it already does and it has forever. Like we're not actually changing anything on the API server side for this. This is purely a documentation for clients, and like here's how you go about comparing resource versions for clients. And if we want to strengthen this with a conformance test that says for the built-in Kubernetes types and for like types served from a custom resource, this is how resource version must behave if you want to be conformant, I think that's a good idea.
Since you just mentioned that, which is like the top issue, the second version of that is like the second issue on that list is like maybe a more crazy version of that. So if you as a client are parsing integers back from the server and they are all nice and comparable, but they go backwards, should you get upset?
I think that should go in the conformance tests, right? Like, if it does go backwards, then that should fail at that point.
Right. So conformance tests will make
think-
sure the server doesn't do that, but conformance tests can't make sure a client
panics. I mean, the error signature means the client has to handle it.
Well,
And
no,
so,
you could get two integers. Like, so today you started your watch, it was a resource version 10, and then you kept going, and then it like went back to 9. Right? So there's no error because it's still integers. Right? But semantically now you've gone back in the past, which you've never supposed to do. Right? So yes, we could even have that in the conformance test, right? But what I'm more talking about, if it's in something
we
like,
never detect that. I mean, it's highly unlikely we would, like, unless it's like happening regularly, right? Like,
right.
I don't know.
Yeah, I comment on your issue. I think it's reasonable to offer some tooling for people that want to opt into safeguards because their controller needs to make that assumption. I think it might be going a little too far to have the default case be that it like panic in a library is code smell. Libraries shouldn't be panicking my code. I should not have to wrap everything with.
That's why I'm asking the
recover.
question. It is a very strong assertion, probably too strong to make within a library, but I could see.
I think it's like the mutation detector or like race detector in Go or something. Like you say, hey, I want to have these things caught, and there's some hook for that. But I think it's very unreasonable to have default code without any opt-in start doing panics
like our
unless the caller
informers.
messed up.
Stuff like our informers that it has very strong expectations of, like, once I start a watch at this version, I'll never see a resource version lower than this version. Now that we are okay with relaxing and telling the clients, you can actually interpret the meaning of these resource versions, if informers noticed that and had the ability to say, like, if I see this going weird, like call this hook or call this thing, and applications can decide, do I want to like go out and come in again? Do I want to panic? Do I want to exit? Like, what do I want to hook into a detection of that scenario? That seems okay.
Yeah, but this just is like, you ain't gonna need it. Like let's. This seems like I think we can defer this implementation until somebody starts complaining.
Yeah, I don't think it has to be related to this, part of this necessarily.
Yeah.
Documenting that clients can interpret resource versions opens the door for detecting that. And anyone who has like done a restore from an etcd backup and their server like restarted resource versions below where they previously were, like we've seen crazy things happen. And if clients could notice that and like not keep charging forward into error states, that would kind of be nice. But the first step is documenting what resource versions mean in a way that clients can interpret, and that opens the door for detection of invalid states and things.
Yeah, I was gonna say earlier, I agree with the conformance test and that we probably should like check that it increments in the way we expect, and that's something that should be pretty straightforward to do. It seems like one thing that we skated past from earlier in the discussion is how many bits and is it signed? We, SIG Arch here, we need to bike shed that one bit. is, is it signed or unsigned? I think that we'll need to settle that.
We should never get a negative resource version. So let's just state that.
I agree with that, but I wanted to tease Han before he left, that you're starting a bike shed about one bit. But yeah, I agree. We should do unsigned.
Bounding instead of unbounded seems like a good idea. 128 bits, like 127 or 128 seems plausible. I don't have specific thoughts about why someone might want to squeeze every last bit out of it. If other people do have specific thoughts, that would be helpful to kind of chip in. And then obviously it has to be greater than 0. It can't be negative. Even if we say it's an int 128, like it would have to be an int 128 greater than 0. So we'd effectively be losing half the space.
Doing sign can make some logic a little bit easier to reason about without promoting to a larger integer. I think that would be the only reason to consider that. Otherwise, I mean, 2 to the end, like that, it does give you quite a bit of extra room.
Yeah. So I don't know that we need to settle all those questions here. If we could sort of take each of those questions and list out the pros and cons and then come to a conclusion. But directionally, it sounds like people are okay with not remaining opaque, telling them it's an int, okay with making it bounded, okay with making it a big bit depth, 127, 128.
Okay with all of that for everything except aggregated APIs.
Yeah. And so aggregated APIs, we would strongly encourage aggregated APIs to fit within this mold just to serve themselves and make generic clients happy with them. And then as we relax and tell clients, you can start interpreting this, we'll give them a way to interpret that makes it clear that an error comparison in the comparison is possible, and they should consider how to handle that.
Merrick, I think, is next.
Yeah, to remind people and think that I even didn't expect, there can be a negative revision, and we support a negative revision, but in continue tokens. If you pass a negative revision in your continue token, it means you want a consistent continue. But I will now go back. But yeah, I think clarifying that and unifying would help a lot.
Yeah, you'll never see an object or a list result come back with a negative resource version.
And yeah, you shouldn't, but you can ask for negative revision. Yeah, for token. Will not. I once read the code. I think there is a lot of signed and unsigned. Because of that, there is conversion for signed and unsigned, and there is some weird things, but if you can figure it out later. I forgot what was my original thing. Oh yeah. As for what Jordan mentioned about assertion and checking if your etcd if you restore etcd, of course we have solution for how to restore etcd safely without going back into revision, but it's not default and it's not something that we can do. But to maybe give you example, just a month or two ago, we had a case that we found out that etcd can go back in the revisions still for watch. Why not? Once a year it happens, we find the case for that. But so let's not assert and crash everyone. Fortunately, it was not horrible, but yeah. And if you are interested, there was a case and it's fixed. And we are testing it more.
Okay, thank you, Merrick. Mo?
I was gonna ask. So I think in the Calico case, right? So they are an aggregate API server. I think what they ended up doing is they just glued the resource versions of 2 separate resources together. I don't remember if they had a separator or whatever, but regardless of that, right? They're very close to teetering on looking like a int 28. So a client could misunderstand what they mean because they're not actually saying that RV is a int 28 128. What they're actually saying is two separate RVs glued together that have very specific meaning. I'm just mostly bringing that up as just a random edge of where you're not going to get an error back from any of these libraries, but the meaning might not be retained, which is unfortunate. I think, and so maybe we have to recommend that clients that interact with generic resources need to have some kind of, I don't know, maybe a priori knowledge of aggregation or something. I don't know.
Calico did have a separator, so it was first rev / second rev, so it would fail parsing. But
yeah, so I guess that was okay. But yeah, but you can kind of see how you could very easily accidentally get into.
I mean, is that true? I guess if they had a separator that was like, we know the first 4 characters are this, and then we have zeros, and then we have.
Yeah, if you were getting overly clever with your bin packing, basically, right, then you can get confused. Maybe it's an edge of an edge, and we don't need to worry about it, and that's just kind of fine. And I'm okay just saying that we're probably gonna not bother more than a fraction of a percent of people. The other thing I wanted to ask is, I'm sure as we are thinking about it now, all of our theoretical use cases fit into like 128 bits. Are we sure that's enough? I don't have any use cases that need that many bits to begin with, but if we're gonna do it, we probably should do it one time and not keep changing it. So
Well, we're not changing the actual type, right? We're just changing the what we say
as soon as
as soon as we say
we
it,
give a client a utility library that takes a string
right.
and parses comparable integers out of it.
Sure, we have to limit it for ourselves, but it doesn't affect. I guess you're saying in our own projects, like within built-in types, are we going to do something crazy? I don't think so. Like, who's going to do something crazy?
No. What I'm saying
as
is,
soon as the client starts parsing it, and we say, you can safely assume that this string will parse as 128-bit for all built-in resources, and we guarantee that in conformance.
Right.
And then 10 years from now, it's like, oh, we want to shard in crazy ways, and we need to encode it to comparable ints because we made that promise, but actually 120 bits isn't enough anymore. We need 256 bits. All the clients that are comparing strings as 128 parsable ints, like we wouldn't reasonably be able to expand the bit length of the built-in Kubernetes API types.
right. And so that's why I'm like, I realize it shouldn't be infinite. I agree that it can't just be a big int and have fun. But at the same time, I don't know for like hurting for bits either. So like, I don't know, 256, 512, I don't know, just pick a number that gives significant margin, not like the tiniest margin we thought at the minute that was enough, right? Like as a for example, right? A lot of crypto protocols love using 256 bit ints. I don't know why that would matter here, but like computers are getting better at that number, so you could do that if that was the case. But I just feel like we should not just do the absolute minimum.
Nobody needs more than 640K.
Yeah, that's kind of what's in my head, right? It's like, how about we give more than we think we will ever absolutely need, while also giving it not a ridiculous size and wasteful of CPU and whatever. And
Those also have to be somewhat reasonable to implement code for it. Like if we pick something like 512, it might as almost well be easier to just say it's a big int because there are actually good libraries for that in most languages, but there probably aren't 512-bit integer types.
Yeah, you'd probably have to homebrew it or something like that at that point, rather.
so we don't have to decide this now, but why would we need the library to return an integer? Why would it not be able to return an opaque interface that just allows comparison across its own?
Well, the whole point of
It
this
doesn't
is
have to
so that
return an
people.
integer, but under the covers, you've linked to code that does a comparison. And so you build a client against a linked utility function at a point in time 6 months from now that we give you. That code, whatever it's doing under the covers, it's parsing to an int or like that has to keep working against future API.
Yeah, right. And so what I'm thinking is like literally that could use a big int and then fail if it goes above 512 bits or something. Or whatever.
But at that point, why don't we just say it's a big int? Like, I think if we're going to say it's a fixed size, it should probably be a fixed size that is reasonable for people to build code with. Maybe that's 256. Right. I'd have to look.
If I were writing the client library, I would totally use big int. Like I don't actually, and then I'm future proof, no matter how many bits we want to give it in the future. But
yeah. Again, we don't have to figure it out now, but I am a little nervous about just doing the absolute smallest number that's slightly bigger than 64.
Is 128 slightly bigger?
I don't know.
That's a lot. That is a lot of bits. I mean, like, you know, we always kid like, oh, no one can need any more. But I mean, if you look at like IPv6, I think it's similar, right? So far, it has proven quite strong. And if you look at the number of things you can represent with that, it starts to get like, okay, so like every grain of sand gets an address or something. I don't know. Are we expecting people to like blockchain is their resource version?
I just don't want to get stuck at some point saying, sorry, we just can't do anything for you because now I'm opaque.
Well, if we make it to the point where we're stuck on the 128-bit RV problem, then I think the project is wildly successful and we will all get well to solve that problem. That we'll have like new RV next to it. It will have our own little mini Y2K.
An alternative.
We should leave some room, but maybe not infinite.
I mean, like the field we send back to clients is already a string. Like an alternative is to say these are comparable as integers with the drop leading zeros and then compares it. Like you don't even have to parse it into an integer at that point. Drop leading zeros, the longer string is bigger. If they're the same length, then you compare lexically. Like then
you don't, yeah, it can be anything.
Like
we can change it later.
We already return them strings. Clients.
So that's a big int, though.
So that's an unbounded integer, but we return them an unbounded string today.
So it's a big int, but we should. I think the when we have the KEP, we should give guidance for how to do this correctly, so that we don't have a bunch of things in the ecosystem go, great, we can do this, and then they start parsing it as like int64. We should tell them explicitly wherever we document this that you should use like string compare, or you should use big int, or.
Yeah.
Okay, I think we bottomed out on this discussion. Anything, unless somebody else has another comment, I think we can wrap it up. Okay, all right. Thank you, everybody. Have a great, what is it? It's Thursday today, so have a great one more day of your week, except for Jordan. And then we'll see you next time.
Yeah.